Hello everyone, this is the video of me answering NEAP 2021 Unit 3 and 4 exam. This is going to be done over several different videos, probably 3 or 4. I'm going to do this video, I'm going to do the multiple choice questions only, and there are another 20 questions beyond that that are worth like 90 or 100 marks, and we're probably going to split that into at least 2 videos as well. So let's get into it. I'm assuming for this that you have the exam with you, all right? So you need to have it. I'm not going to show it. Here it is. I do have a copy of it here, but I'm rarely going to actually show the questions on this. We're not going to be working from this. We're going to be working from my description of the answers, which are going to be on this paper here. All right, so I'm assuming that you have it with you. I'm also assuming that you have your cheat sheet with you just in case you want to add something to it, or at least a notepad just in case you want to take down a few notes from what I'm saying and what I'm describing here. All right, let's go. Okay, question 1. It says a current carrying wire is carrying current out of the page. This is it, and it's near a magnet. And there's a point P between these two things. You can see the diagram on your own question. I'm assuming you've got it there. Just move it across a little bit. And the question is, which direction is the magnetic field pointing at point P? Well, according to this, from this magnet, it should be going that way, right? Because North Pole magnetic field lines radiate out from the North Pole. So if it was just due to the magnet, again, you ignore the other one, just due to the magnet, it'd be going right, right? This current carrying wire, you're going to use this right-hand screw rule to figure this out. Your thumb is going to go in the direction of the current, and your fingers will wrap around in the direction of the magnetic field. You've seen that before. I'm using my right hand because they didn't say electron flow, they said current, so we're assuming it's right-handed. It's conventional current, right? So I'm going to do that this way because that's the way it's been drawn coming out of the page, and that means my fingers will wrap around anti-clockwise. So wrapping around anti-clockwise at P, that field is going to be going down. So I'm just going to draw P again over here. It's feeling one magnetic field there, another magnetic field there. The resultant of those two vectors is about that way, and that arrow is B. So the answer is B. All right, question 2. This is a standard electric field strength question. It just says a charge has a magnitude of 10 microcoulombs. Which one of the following is closest to the magnitude of the electric field 1 millimeter away from that charge? Here's the formula to use. The other thing that this is really testing that's not mentioned here is your ability to convert units. They gave you microcoulombs, they gave you millimeters. It has to be in coulombs, it has to be in meters. Okay, so K is on the formula sheet. You just had to get the units right for these two. Do the calculation, find the answer. The answer is D. Okay, question 3. I am going to show you this picture. So this is actually question 3. A charged particle, an electron, goes into a magnetic field that's going into the page. It gets bent according to the left-hand rule. It's going that way, it's going to get bent down, and then ends up taking a circular path, and it comes out at point N. If the speed of that electron is dropped to half of its value and the strength of the magnetic field is dropped to half of its value, which point would it now exit? In other words, will that circular path be bigger or smaller? Will it have a bigger radius or a smaller radius? Right? Here's how to work it out. So mv squared on r, this is a useful thing. Every time something is going around in a circular path, that's the reason it's doing it. Right? That is the formula for the force that something needs to go around a circle of that, excuse me, around a circle of that radius at that speed if it weighs this much. Right? This, in this particular case, is the source of the force that's pulling it into the circular path. Right? That's what it needs to make that circle, and this is what it's got to make that circle with. So you juggle this around and you get a formula for the radius. Right? And the radius ends up being mv over bq. Now they said in this question that the velocity was going to be halved, and excuse me. And the magnetic field strength was going to be halved. Now, if that number is halved and that number is halved, this fraction is not going to change at all. So the answer is it should not change a thing. It should still go out at point N because it's gone out at point N the first time. So the answer is C. This is a bit of an annoying question 4. I'm going to show you this as well because they've made it ambiguous a little bit. So here's the situation. They don't tell you how many volts this is, but there's a voltage, there's a potential difference between that plate and that plate. There's an electric field obviously between the two, and at point P there is a certain electric field strength there. Right? And they said that the number of volts of potential here is V. I wish they'd have said X or something, right? Because down here this would have been 5X, 10X, 10X, 5X. They're not actually saying 5 volts there and 10 volts. They're saying 5 times whatever that V is and 10 times whatever that V is, right? So I think it was a little bit misleading because they just happened to choose the value, the letter V for the unknown here for volts. Any other letter would have been all right, but they had to choose V, didn't they? Anyway, this is how the question goes. They're saying, excuse me, which one of the following correctly represents the potential and the magnitude of the electric field strength at P, pardon me. I keep saying B. Okay, now the potential drops from the maximum to 0 when you go from plus to minus, right? So if you're at the maximum there and you're 0 there, then if you're halfway between the two, you must be halfway up to the maximum. And the maximum is V, so the potential at P is V divided by 2, right? If you're halfway between the plates, you're experiencing half the potential that that electric field has to offer, right? So that's the potential. So V on 2 is the answer over here, so it's got to be B or D. So the answer is D, and here's why. The formula for for electric field strength is this, right? Voltage divided by distance, right? Now we don't know what the voltage is. They just said V volts, so we've just got to leave the V as it is. But the distance between them is 20 centimeters because they said in the question that the point P was a distance of 10 centimeters from each plate. So the total distance between the plates must be 20 centimeters, which is 0.2 meters. V divided by 0.2 is the same as V times 5, so it's 5V. And that's why the answer ends up being D. That's a little bit of a misleading question though. Question 5, they have given you this graph. They have said that there is a loop of wire with a current in it, and there's a loop of wire that's rotating within a magnetic field between two magnetic poles. They didn't tell you what sort of commutator it has, but they have shown you the graph of the EMF that it produces. Okay, and they've said, well, which one is it? Okay, so firstly, if there's no up and down, if there's no actual changing of the direction of the EMF, then the voltage must be rectified because a loop spinning inside a magnetic field will always make AC. This is no longer AC, this is now DC, so it has been rectified, it has been corrected. And the only way to do that is with a split ring commutator, and they are split ring commutators, so it must be either A or C. So forget those two. And it must be A because C has got 2 north poles there, which doesn't give us a straight line magnetic field from one to the other. You need straight lines for the loop to be spinning in for this to happen at all. All right, so that won't do a thing, and this will make exactly that. So the only possible answer there is A. Question 6 is just testing whether you know how to calculate RMS. The graph has a peak voltage of 5. Right, just up there. They didn't say it in the messaging, they didn't say it here, they didn't say it there. You had to read the graph. This is why I keep saying, when you see a graph, stop for 10 seconds and just have a look at it. There is information there that they're trying to hide from you. Question 6 says the RMS value of the EMF output is what? That's the peak. Peak divided by a square root of 2 is RMS. So you divide 5 by the square root of 2, it can only be 3.54. This is a bit of a shortcut here, right? Multiple choice questions often require calculations, but because they're only worth 1 mark, they tend to do these things in a way that gives you a shortcut, right? 5 divided by root 2 is going to be less than 5. So you don't even need to pick up the calculator. If there's only one of these things that is less than 5, it had to be A. You didn't need to touch a calculator for this question, and that saves you a little bit of time. Often there are little shortcuts like that in multi-choice questions because the people writing them understand that you're only going to get 1 mark for it, so they try to make it fast to do. Here's question 7. 2 masses M1 and M2 hang over a pulley with a string. M2 is heavier than M1, so the whole thing is accelerating that way. M2 is accelerating downwards. And you're asked to compare the tension in the string to M2G. So have a look over here. This is just what M2 is experiencing. I'm just ignoring the rest of that. We're just looking at M2. M2 is being pulled down by its own weight, which is M2 times G, right, mg, and it's being pulled up by tension. If they were the same size, there'd be no acceleration. It's accelerating that way. They said that in the question, so this must be a bigger force than that. Right? It's winning. It's accelerating that way. So therefore, the tension must be less than that. So whichever one says that, and that'll be C because I've already written it, yeah, tension is less than M2G. That's why. Question 8 is an impulse question. Sorry, I'll just fix the camera work here. Just give me a minute. There you go. Right. Question 8, there's a force, there's a time, it's going to be impulse. All right. So a boy of mass 60 kilograms squats down, then jumps up vertically. Excuse me. He takes 0.5 seconds to jump from rest to 4 meters per second. Now you can do this two different ways. You can go force times time, or you can go change in momentum. I decided to do change in momentum, mv, right, minus 0, so that's his final momentum, that's his initial momentum, 240 newtons. Could have done it the other way, doesn't matter. Pretty easy question. Okay, question 9. This is a classic graph question. The answer is get the area under the graph, right? The graph shows gravitational force acting on a falling object versus its position from the center of the Earth, in other words, its height. And they're asking you for the work done. The work done by anything is the change in energy of something. If I do 10 joules of work on an object, it gets 10 joules of energy from me. Now, this thing is changing its height. Right? Its position from the center of the Earth is going from 6.38 million meters, which is 6.38 thousand kilometers, to 7.16 thousand kilometers. It's going higher. Right? And the gravitational force is getting a little bit lower as it does that. So that is H, and that is mg, gravitational force. So if you multiply those two together, you get mgh, which is the formula for gravitational potential energy. Okay, so whenever you can multiply the vertical and the horizontal quantities on a graph, get the area under the graph. The area under the graph is the product of those two things. So we can just get the area of that triangle, right, because it's from there to there. Get the area of that triangle, including this bit as well, sort of a trapezium. And that is the answer. So you figure out what the answer is. Excuse me, for getting the area. And the area under the graph is the work done because that's the change in energy. Turns out to be C, but that's how to do it. There is a much longer, more laborious way to do it involving calculating stuff. But really, again, this is worth 1 mark. They were expecting you to try to find the short way, and that's the shorter way. Question 10, classic Lorentz factor question. It's just asking you to use this formula. You've seen it 100 times before. It will be on your cheat sheet because who would be crazy enough to not have it on your cheat sheet if it isn't on the formula sheet? They've given you that number. They're asking you for that number. Call C1 and solve for V. Right? It's a bit of an algebraic pain in the neck, but it's reasonably easy to do. Right? And the answer was B. Okay. Question 11, answer was A. Progressive transverse wave passes through point P. The wave is traveling to the left. Be careful about this. As the wave goes to the left, point P, if it's going to avoid the wave, point P is going to have to go up as that crest travels along. Right? So just imagine point P is a surfer who is on his surfboard beyond the brakes, and the waves are going that way. He will eventually go up. Okay, so the answer was A, upwards. Question 12, this is a straight content question. You either know the answer or you don't know the answer. The answer is B here. You just needed to find two properties about these particular types of electromagnetic radiation that were both true. Excuse me. And yeah, microwaves have less energy than infrared and they're useful for communication. So that was the one that was correct. So you either knew that one or you don't. Question 13, dispersion of a beam of white light through a triangular glass prism is shown in the diagram below. Which one of the following statements about this is right? I believe it's the first one. The refractive index of the prism is greater for higher frequency colors, right? Red is the lowest frequency, lowest energy, and violet is higher. So if violet bends more, it's got to have a higher refractive index. So A is true. Question 14 is about polarization of light. The polarization of visible light occurs when a property of light waves oscillating in various planes is affected. Which thing is affected? Amplitude is affected. The fact that the transverse waves go up and down like that means that they couldn't go through a horizontal grate, right? So if there are lines like this and there is a wave trying to go up and down, the amplitude is too big to fit through the grates. If the amplitude is going that way, it can fit between my fingers, right? So it doesn't matter what the wavelength, the period, or the frequency is, it's just the amplitude. And more so the direction in which the amplitude is going rather than its side. Okay, question 15, just let me get this a little centralized for you. There you go, a bit more. Okay, 15 is worth having a closer look at. Two cars going towards each other, or a car and a truck going towards each other. This is Wally, this is Dave, and this was Jennifer, I think. Jenny, yep. Jenny standing still. Truck sounds its horn. The horn's waves go towards these two other people. Right? And because Dave is moving, the horn is going to sound a little bit higher pitched than it would otherwise sound. David is going to hear the horn as it is, as it really is. But Jenny is going to hear a slightly higher pitch because as each wave gets pumped out of the front of the truck is slightly catching up to the wave. And so that brings the next peak a little bit closer to the last peak than it would otherwise have been, making the pitch of the sound higher. Right? So Jenny's going to hear it slightly higher, but because Wally is actually going towards it, he's going to get the peaks in with a shorter time gap between them than Jennifer is going to be, because he's catching up to the peaks as well. So he's going to hear it higher than either Jenny or David. So David's going to hear it as it is. Jenny's going to hear it a little bit higher, and Wally's going to hear it higher still. So the answer to that question was D. Question 16, this is about sound waves diffracting and about the conditions that maximize diffraction. It basically says which one of these situations will create the greatest diffraction. Well, the rule is basically diffraction is greatest when the ratio of the wavelength to the gap is closest to 1, right? So basically you had to do a bit of calculation for this. You had to do, the ratio of those two 4 times. So it's a bit of a pain in the neck, but these were the 4 answers. And the one that was closest to 1 was going to be the most diffraction, so that's A. Question 17 is an E equals MC squared question. This is, excuse me, this is just asking you to figure out whether you know what the M is. The M is the mass defect. It's the difference between how much matter something had before a nuclear reaction versus how much at the end. All right, so creation of a helium nucleus in the sun can be modeled by the fusion of 4 protons. So the initial mass is the mass of the 4 protons. Right? The answer is C. I may as well point to C. The initial mass is the mass of 4 protons. It turns into a helium nucleus, which will be lighter than 4 separate protons, hence the mass defect. So this is what we need to do. That's helium minus 1 proton. First, it's the wrong thing minus the wrong thing. And this is just backwards. You're going to get a negative result. And that doesn't take into account the mass defect at all. So the answer is C. Okay, question 18. This is a classic Heisenberg's uncertainty principle question. The uncertainty in the Y position of this electron, there's an electron going through a gap, and there is an uncertainty as to where it will go through the gap. It might be there, it might be there, it might be there. Bit of uncertainty there. Okay. Depending on how uncertain that position is, that will affect the uncertainty of where it is going to go, whether insofar as whether it's going to go left or right or straight ahead. It won't affect how fast it continues to go in the X direction. So it has no effect on the X uncertainty of its momentum. Right? It does have an effect on the Y uncertainty of its momentum, because the narrower that gap is, the greater the certainty, the lesser the uncertainty, I should say, of its position going through here. In other words, with a narrower tunnel, with a narrow gap, the greater the uncertainty is in its momentum, but it's the vertical momentum that's uncertain. Okay. So the answer is A. 19, you either know it or you don't. This is another straight content one. Which one of the following instruments is responsible for the production of light by forced circular motion of high-speed electrons That's what synchrotrons do. D. Ask me next term if you don't know what that is. All right, question 20. This is about reliability and validity. A correctly calibrated data logger, so it's not going to make a systematic error. Determines that the frequency of the note of a guitar playing is 440 hertz. A group of students use the same guitar string to record the note on a different data logger. Their results are shown below. So it really is 440. We have that with some certainty. All right. The data is reliable because it's all very damn close, right? And it's all within the plus or minus 2 hertz, by the way. Okay. So it is very reliable. It's very predictable. You would expect that if you did it again, you'd get something between 450 and 452. That's reliable. Okay. However, it isn't valid because we know that the truth is 440. There's a systematic error in here. The second data logger must have had something wrong with its calibration.